Let's discuss the integer exponents. Suppose n is a natural number. That is, n can be 1, 2, 3, 4, okay? Then b to the power n equals b multiplied in b, multiplied in b, multiplied in b, until the final b. This is multiplied in each other n times. Okay? Definition. For any non-zero real number b, b to the power 0 is equal to 1. For example, 3 to the power 0 is 1. 3 over 4 to the power 0 is 1. Minus 7 to the power 0. Here the base is 7. So the answer is minus 1. Minus is outside and we are dealing here. Okay? A square plus 1 to the power 0 is equal to 1. This is the rule for any non-zero real number. We know the real numbers. Any non-zero. This is known as the definition of b to the power 0. Let's now take the definition of b to the minus n. If b is not equal to 0 and n is a natural number, then b to the power minus n equals 1 over b to the power n, and 1 over b to the minus n equals b to the power n. For example, 3 to the power minus 2 equals 1 over 3 square equals 1 over 9. Also, 1 over 4 to the power minus 3 equals 4 to the power 3 equals 64. Also, 5 to the power minus 2 over 7 to the power minus 1 equals, this will go up and this will go down, equal to 7 to the power 1, we will never write 1 here, over 5 to the power 2, which is eventually 7 over 25. Let's take example to evaluate an exponential expression. The example says evaluate the exponential expression. The first question, A, minus 2 to the power 4 multiplied with minus 3 to the power 2. So this is equal to what? Minus is outside, of course, because the base is 2. So 2 multiplied in 2 multiplied in 2 multiplied in 2 4 times, multiplied in minus 3 all square, so the base is minus 3. So here it is minus 3 multiplied in minus 3. Okay, this is equal to minus 16 multiplied in 9. The second question, minus 4 to the power minus 3 over minus 2 to the power minus 5. This is equals minus, of course, what we will do right now, this, since it is negative, the whole expression will go down with a positive 3, and this is negative, will go up with a positive 5. So this is equal 2 minus 2 to the power 5 over minus 4 to the power 3. This is equals eventually minus 2 multiplied in itself 5 times. Okay, over minus 4 multiplied in itself 3 times. So this is eventually equal to minus 32 over minus 64. Then negative divided by negative is positive. The answer at the end is half. What about C? Minus pi to the power 0. So it should be minus multiplied in 1, which is minus 1. Any value to the power 0 is 1. The final question is minus 4 to the power 2 over 2 to the power minus 3. This is equals eventually 4 to the power 2 and 2 to the power 3. So this is equal to 2 multiplied in itself 3 times and 4 multiplied in itself 2 times. So the final answer is 8 over 16 equals half. We are done. Please note that the expression 0 to the power 0 or 0 to any negative, okay, these two values are undefined. Okay, 0 to the power negative number can be written 1 to the power 0 of the positive number, or if you say it in another way, 0 to the power minus n is written as 1 over 0 to the power n. These values are undefined. Okay, they never exist. For example, if I give you an example in expressions, okay, in expressions, if an expression such as x to the power 0 multiplied by y to the minus 3 over z minus 4. Here x cannot be 0 because this will be 0 to the power 0, and y cannot be also 0 because here y is to the power of a negative number. It would be 1 over y to the cube. It would be 1 over 0 cube, which is undefined. Also, if you look at the base here, z also, and z cannot be 4 because 4, if you put z here 4, it would be 4 minus 4, so the denominator will be 0, which is unacceptable. Okay, another expression, a minus 1 to the power 0 over b plus 2. Here a cannot be 1 because if it is 1, this will be 0, and we will be left to 0 to the power 0, which is unacceptable. Okay, also b here cannot be minus 2 because if you put b here minus 2, this would be minus 2 plus 2, and we will have 0 here in the denominator, which is unacceptable. So focus please in the note I gave you. Okay, 0 to the power 0 is undefined. 0 to the power 0 is undefined, and 0 to any negative number or 0 here in the base to any here. If you put here any number, it doesn't matter. If 0 here in the base or the denominator, it should be unacceptable or undefined. Okay. Properties of exponents. Let m, n, and v are integers and a and v are real numbers. The first property is the product of exponents with the same base. The product of exponents with the same base. Let the base b to the power m multiplied into the base b to the power n. This is equal to what? It is equal to base b to the power m plus n. This is the first property. The second property is the quotient of two exponents with the same base. The quotient of two exponents with the same base, I mean the base b to the power m to the base b to the power n, equals to the base, then m minus n to the power m minus n. Okay. This is the second property. The third property is the power. The power of an exponent b to the power m. This exponent, if we say it is to the power n, then it is equal to what? We multiply n into m. So it should be equals to b to the power m n. Also another form of the power, if we say exponent a to the power m multiplied in exponent b to the power n. They are different bases. Okay, you cannot say we will add these together. No, they are different bases. If we say a to the m multiplied in b to the n all to the power p, okay, this is equal to this b multiplied in m and this b multiplied in n. Okay, so the answer should be a to the power m p multiplied in b to the power m p. The final property, which is in the form of power, if we say a to the power m over b to the power n all to the power p, okay, this is equals to b p multiplied in m multiplied in n. Okay, so it should be a to the m p over b to the n p. Please note that here, okay, b shouldn't be equal to 0. We know that because b will be in the denominator. Okay, so b shouldn't be equal to 0. Also here b is not equal to 0 because b will be in the denominator and we don't want a denominator to be 0. So what are the properties that we studied right now for the exponents? The first property is the product. The second property is the quotient. The quotient. Okay. The third property is the power. In the power, it was three forms. This is the first form, second form, third form. And that's it, the properties of exponents. Let's take examples to demonstrate our understanding. Okay, if I tell you a to the power 4 multiplied in a cube, okay, what is the answer of this? Okay, we have the same base, a here, and a here. Okay, we can add this power to this power to this power. Of course here nothing is written here, but we know it is 1, so the answer should be a to the power 4 plus 1 plus 3, okay, which is eventually a to the power 8. Another question, x to the power 4 multiplied in y cube multiplied in x y to the power 5 multiplied in z square. This is equal to, we can now gather x's, okay, together. We can say x to the power 4 plus 1, okay, so it should be 5, and we can gather y's together, so it should be y to the power 8, and we z, there is nothing to combine with, so it will remain the same, z to the power 2. Okay, the third question, if I tell you a to the power 7 multiplied in b over a square multiplied in b to the power 5, this is equal to what? This is equal to, let's take a first, a to the power 7, okay, minus 2, 7 minus 2, okay, multiplied in b to the power 1 minus 5, that is 1 here minus what? 5. So the answer should be a to the power 5 multiplied in b to the power minus 4 equal to a to the power 5 over b to the power 4, because this is equal to 1 over b to the power 4. The third question, ub cube to the power 5, this is equal to what? We know that this is multiplied in here and this is multiplied in here, so it should be equals to u to the power 5 multiplied in b 3 multiplied in 5, okay, so if it is eventually equals to u to the power 5 multiplied in v to the power 15. The last question, 2x to the power 5 over 5y to the power 4 all to the power cube, this is equal to what? We can say this 3 should be in here and in here, similarly it should be multiplied in here and also here, okay, so the final answer will be 2 to the power 3 multiplied in x, 5 multiplied in 3 over 5 to the power 3 multiplied in y to the power 4 multiplied in 3, so this is equal to 8 multiplied in x to the power 15 over 125 multiplied in y to the power 12. Now let's take examples to demonstrate our understanding. Simplify the exponential expression. 5x squared multiplied in y between parentheses multiplied in minus 4x squared y to the power 5 between parentheses. If we see that x here and x here, okay, and y here and y here. You combine the powers of x and the powers of y. So first we combine the power of x. Okay, the power of x should be x to the power 2 plus 2. Okay, 2 plus 2 multiplied in y to the power 1 plus 5. Okay, what about these two numbers? 5 multiplied in minus 4, it is minus 20. Okay, the final answer should be minus 20 x to the power 4 multiplied in y to the power 6. The second question, 3x squared multiplied in y multiplied in z to the minus 4 all to the power 3. This is equal to, this of course will be multiplied in the power of z multiplied in the power of y multiplied in the power of x. So 3 is, and also do not forget 3 also should be a power of 3 of this number. That's it, 3 to the power 3. Okay, this power should be at the top of each one in between the parentheses. So 3 to the power 3 multiplied in x to the power 2 multiplied in 3 multiplied in y to the power of 1 multiplied in 3 multiplied in z to the power of minus 4 multiplied in 3. So the final answer is 27 x to the power 6 y to the power 3 z to the power minus 12, which is eventually equal to 27 x to the power 6 y to the power cube over z to the power 12. The third question, minus 12x to the power 5 multiplied in y over 18 x squared y to the power 6. How to simplify that? This is an easy task, of course. This is an easy task. Should be here minus 12 over 18. We would put it aside. Okay, x to the power 5 over x to the power 2 should be x to the power 5 minus 2. Okay, multiplied in y to the power 1 minus 6. So this is eventually equal to, if we see here 12 over 18, if we take a factor of 6 as a factor, this should be minus 2 over 3. Okay, multiplied in x to the power 3 multiplied in y to the power minus 5, which is eventually equal to minus 2 over 3 x cube over y to the power 5. The fourth question, 4p squared multiplied in q over 6p q to the power 4 all to the power minus 2. This is, if you proceed it would be okay. However, if we simplify what is inside here before we take this inside, it should be better. We don't want to complicate things. So this is, can be written as 4 here, 4 over 6. This is simplified as 2 over 3, right? Okay, so 2 here, down 3. What about p squared over b? Should be p squared minus 1, right? Okay, multiplied in what? q 1 minus 4. So this is eventually equal to 2 over 3 b to the power 1, of course we will leave it, q to the power minus 3 all to the power minus 2. So this is eventually equal to, if we take this inside as before, 2 to the power minus 2 multiplied in p to the power minus 2 multiplied in q to the power 6 over 3 to the power minus 2. So this is eventually, this will go down and this will go up, right? So with different signs of power. So this is equal to 9 over 4 multiplied in p to the minus 2, but p to the minus 2 will go where? Down. Should be b to the power 2, and here q to the power 6 will remain the same. So we now finished the answer. Our last question is minus 3 multiplied in a square b cube to the power 2 over minus 2 multiplied in a b to the power 4 all to the power 3. So we can do something here. Okay, so if we take this power will be multiplied in each. Of course, this is would be minus 3 to the power 2 a, okay, a, because we have here different, so we cannot do the same what we have done here. We cannot simplify. Okay, so 8 square multiplied in 2 should be 4. Okay, b cube multiplied in 2 should be b to the power 6 over minus 2 now to the power 3 a to the power 3 b to the power 12. Now we can simplify. What can we do? Minus 3 square is 9 over minus 2 cubed should be minus 8, of course. What about 8 to the power 4 over a to the power 3 should be a to the power 4 minus 3, and b to the power 6, and here b to the power 12 should be b to the power 6 minus 12. So the final answer should be minus 9 over 8 multiplied in a to the power 4 minus 3 should be a. b 6 minus 12 should be b to the minus 6. So b to the minus 6, and it will go down b to the power 6, and we are done. Let's discuss the scientific notation. The scientific notation topic, we are going to transform the decimal form to the scientific notation and vice versa. That is the transformation from decimal form to the scientific notation and vice versa. Okay, now how is this made? Okay, before we proceed, we have to know what is the decimal form and what is the scientific form. The decimal form is, for example, if we say 7,430,000, okay, and its scientific notation is written as 7.43 multiplied in 10 to the power 6. How is this made? It is made by putting the decimal point, this is the decimal point. Again, it is made by putting the decimal point to the right of the first non-zero digit. How we are going to do that? Suppose in our example 7,480,000. Okay, to transform to the scientific notation, we are going to put the decimal point to the right of the first non-zero digit. This is the first non-zero digit. So we put the decimal point here and we transform it to the scientific notation. Okay, the decimal point at the right of this non-zero digit here exactly, and we calculate how many decimal places. This is number 1, 2, 3, 4, 5, 6. Then we transform to the scientific notation. So The final answer should be, in transforming to the scientific notation, 7.4 multiplied in 10 to the power 6. Another example, if I tell you to transform 0.0000078. So how we are going to transform it to the scientific notation? We put a point, the decimal point, after the first non-zero number. So this would be at the end 7.8. okay, multiplied in what? If you put the decimal places here, calculate now from the after the point. So here is our point should be. So this is 1, 2, 3, 4, 5, 6, 7. Then this is multiplied in 10 to the power minus 7. Okay. Another example, if I tell you to transform to the scientific notation this number, 3.5 multiplied in 10 to the power 5. This is the scientific notation already. There is a number, after it there is a decimal point, okay, then what is left multiplied 10 to the power 5. This is the scientific notation. Now we are going to transform it to the decimal form. So this should be 3, 5. Then how many decimal places we were in? 5, right? So this is calculated 1, and there should be the left, which is 5. So this is 1, 2, 3, 4, 5. This is our final transformation. Okay. Another example, if we have 2.51 in the scientific notation multiplied in 10 to the power minus 8. So if we transform it to the decimal form, to transform this into a scientific, to transform this decimal form into scientific notation, we are going to have a number like this. We have here, we are going this side, right? So we have here 1. So this is 2, 5, 1. Okay, we have here 1 decimal place, which is at 2, and what is left? The other 8. This is first decimal place. This is the second, third, fourth, fifth, sixth, seventh, 8. Okay, then we are done. We transform it to the decimal form. As you see, from here to here we have 8 decimal places. Okay, and similarly here, from here to here we have how many decimal places? We have 7 decimal places. Okay, and I think this is going to be easy. If we take an example, if I tell you put this number 0.5 multiplied in 10 to the power 7, put it in the scientific notation. This is not a scientific notation, by the way, because we must have a number like 7 point something. We don't expect in the scientific notation to start with 0. This is not a scientific notation. You have to start with a number, then you go. So how to start with the number here? We would say, okay, we will move this 1 decimal place, okay, and we will reduce from this. Okay, so this is eventually equal in the scientific notation 5.0 multiplied in what? 10 to the power 6. This is a scientific notation. The example says perform the operation and write the answer in scientific notation. So we have to perform the operation. Now we can say what this 6.9 and this is 8.1. So we will multiply 6.9 multiplied in 8.2, okay, and we multiply, of course, in 10 to the power 27 multiplied in 10 to the power minus 13, so it should be 10 to the power 27 minus 13, okay, over 4.1 to the power 15. 5 divided by 100, this one should be 56.58 multiplied 10 to the power 27 minus 13 should be 10 to the power 14 over 4.1 multiplied in 10 to the power 15. This is eventually equal to 13.8, and this is, of course, should be 10 to the power 14 multiply 10 to the power 14 minus 15, so it is 10 to the power minus 1. So this minus 1 will shift things up. We have to write it in the scientific location, so this should be 1.38 multiplied in 10 to the power 0, which is 1, or you can leave it. Of course, we will eliminate this in the if you write the answer, but in the form, if it is asked to write in the form, keep this. Okay. Now let's discuss the rational exponents and radical. What do we mean by rational exponents? If we have 2 to the power 1 over 5, here we have a rational number, okay, so this is a rational exponent, okay. How to deal with that and what operations we are going to make using this rational exponents, okay. Let me introduce to you the one operation we had in the exponents, the normal exponents we had, where the real number b to the power n, this was an integer, okay. Now this would be changed to a rational number, okay. So let me introduce you to the operation we had before. If we say, for example, 2 to the power 5 multiplied in 2 to the power 6, this is equal, eventually we will add these together, 2 to the power 11. What about rational exponents? If I say 2 to the power half multiplied in 2 to the power half, what is the answer? Okay, to understand that, let me compose one thing to you. 9 to the power half multiplied in 9 to the power half. If we add these together, half plus half should be what? Should be 1, right? So 9 to the power half multiplied 9 to the power half is 9 to the power 1, which is 9, right? So what is this exactly? This tells us what 9 to the power half could be written as square root of 9, and 9 here to the power half, it could be written as square root of 9. So square root of 9 multiplied in square root of 9 is 3 multiplied in 3, so the answer is 9. Okay, this is the first part I would like to talk with you about. Thus b to the power 1 over n, okay, can be defined as roots, okay, as the following. We have two cases, okay. The first case, in which we say if n is an even positive integer, n is an even positive integer, okay, and b is positive and or equal to 0, okay. So if b is positive or equal to 0 and n is an even positive integer, then again, if n is an even positive integer and b is positive or equal to the 0, then b to the power 1 over n is the non-negative real number, such that b to the power 1 over n to the power n equals to what? B. The other case, if n is an odd positive integer, if n is an odd positive integer, then b to the power 1 over n is the real number such that b to the power 1 over n all to the power n equals b. So what do we have here? We have two cases. We have two cases. When n is an even positive integer and when n is an odd positive integer. In case of the first one, when n is an even positive integer and b is positive, should be positive or equal to 0, shouldn't be negative at all, okay? In case of the even, okay? Then b to the power n is the non-negative real number such that b to the power 1 over n to the power n equals b. However, in the case of it is odd positive integer, b to the power n is the real number such that b to the power n all to the power n equals b. We didn't say non-negative, we didn't say anything. So in the case of odd positive integer, we are saying about n, okay? And in the case of even positive integer, when we talk about n, okay? So what do we mean by that? Let's take example to understand more. To answer this, let's look at 25. 25 is what? Is 5 square, right? All to the power half. So this half multiplied in half, so the answer is 5. This is another way to look at it. Okay, let's take another example. Minus 64 all to the power 1/3. Okay, so b here, b is not conditioned in case of an odd positive, okay? So b can be negative, no, it's okay. In case of odd positive n, so this should be minus 4 to the power 3, okay? This is minus 64 all to the power 1 over 3. So the answer should be eventually minus 4. Now if I say 16 to the power half, this is equal to 4 squared to the power half, right? 16 is 4 squared, so this is eventually will equal to 4. What about minus 16 to the power half? Minus 16 to the power half. This is equal to minus 16 to the power half, like this, okay? So it should be minus 4 squared to the power half, so this is equal to minus 4. What about minus 16 here all to the power half? This is not a real number. Here before, here the negative is multiplied outside, but what about this? This all to the power half. So if you remember the case, if here it is positive even, b should be greater than or equal to 0. However, b here is negative, so this is not a real number. So not a real number. Okay. The final example, if I tell you minus 32 to the power 1 over 5. Okay, here we have positive odd, so we don't care about if the base is negative. So our answer should be, here we say minus 2 to the power 5. We know it is equal to minus 32, all to the power 1 over 5. So our answer should be minus 2. And this is how you deal with rational exponents as a first property to play with. In the previous slide, we studied the base to the power 1 over n. Now, if we extend our understanding to study cases where b is to the power m over n. Okay, so what are we going to do? There is a definition. Okay, the definition says for all positive integers m and n, such that m over n, in the case of course b to the power m over n, is in the simplest form. This means m over n in the simplest form, like 2 over 3, 4 over 3, 6 over 4, 6 over, let's say 6 over 4 is not in the simplest form. The simplest form is 3 over 2. Okay, this is what we mean by the simplest form number. Again, for all positive integers m and n, such that m over n is in the simplest form, and for all real numbers b, it means that this is a real number b, which b to the power 1 over n is a real number, then we can say b to the power m over n can be written as b to the power 1 over n to the power of m. Also can be written in another form, b to the power m to the power 1 over n. That's it. b to the power m over n equals b to the power 1 over n all to the power m, because m, if it is multiplied in 1 over n, should be m over n. And also can be written as b to the power m all to the power 1 over n, because if this multiplied in m, should be m over n. And this is the definition. If we take an example, 8 to the power 4 over 3 can be written as 8 to the power 1 over 3 all to the power 4. This is eventually equals 2 to the power 4, which is equal to 16. Also, 8 to the power 4 over 3 equals 8 to the power 4 all to the power 1 over 3. 8 to the power 4 is equal to 4096. If it is to the power 1 over 3, which is the cubic root of this number, it is equal to 16. So either way is a correct way. So it doesn't matter if you choose b to the power m over n equals b to the power m all to the power 1 over n, or you can choose b to the power 1 over n all to the power m. We will see when we go for examples and simplify. Okay, now let's take an example to assess our understanding. 64 to the power 2 over 3. This is equal to what? We can write it as 64 all to the power 3, 1 over 3 to the power 2. Why is that? Because we know that 4 multiplied in 4 multiplied in 4 is 64. So it would be easier to choose this one. Okay, 1 over 3. So this is equal eventually 4 square, which is 16. The second question, we know that 32 is 2 to the power 5. 2 to the power 5 equals 32. So 2 to the power 1 over 5 would be easier for us, to the power of minus 3. Okay, so this is eventually equal to 2 to the power minus 3. which is equal to 1 over 2 to the power 3, which is equal to 1 over 8. Another question, 16 over 81. We can do something with this negative sign. So this is equal to what? You can give the reciprocal of what is inside and change the sign. 3 over 4. 3 over 4 here transformed to the positive 3 over 4, and we flipped this one. Okay? This is equal to 81. We know that it is 9 multiplied in 9, which is 9 multiplied in 9. This is equal 3 to the power 2 multiplied 3 over 2 to the power 2. So it is 3 to the power 4. 8 is 3 to the power 4. So we can do something here. 8 t1 to the power 1 over 4. Okay, over 16 to the power 1 over 4. Because we know that 16 is 2 to the power 4. So 16 to the power 1 over 4 would make things easy. All to the power 3. So this is equal to 3 over 2 all to the power what? 3. This is equal to 27 over 8. Another question, 16 over 25 all to the power 3 over 2. So this is equal to, I would say, 16 to the power half over 25 to the power half all to the power 3. So this is equal to 4 over 5 all to the power 3. So this is equal to 64 over 125. And we are done. Now let's discuss the properties of rational exponents. We studied before the properties of exponents in general. However, this is similar, doesn't differ at all from the properties you studied before. So let's assume that P and Q and R are rational numbers, okay? And let's assume now A and B are positive real numbers. Let's see the properties together. The product of two rational exponents, for example, b to the power p multiplied in b to the power q equals what? We will add these together. So similar base p plus q. The quotient, if we say b to the power p and p to the power q, this is equals what? This is equal to b, of course, this minus this, to the power p minus q. The power, if we say b to the power p all to the power q, we will multiply q into p. So we will have the same base, p multiplied in q. Also, if we say a to the power p multiplied in b to the power q all to the power r, this is equal a to the power p multiplied in r multiplied here in b to the power q multiplied in r. So r distributed here, okay? Also, if we say a to the power p over b to the power q all to the power r, so we will distribute it. This will be here multiplied in here as well. So this is equal a to the power p multiplied in r over b to the power q multiplied in r. Also, if we say b to the power minus p, this is equal to 1 over b to the power p. And that's it. Now let's take an example to understand. If an example comes saying simplify, okay, the first item to simplify is 2x to the power 1 over 3 multiplied in y to the power 3 over 5 all squared multiplied in 9x cubed y to the power 3 over 2 all to the power half. How to solve that? Let's start from left to right, okay? If you look at this expression, how many bases we have? This is the first base, this is the second base, this is the third base, okay? This means this exponent will be multiplied in each exponent of the bases, okay? So let's see how this is done. This is equal to 2 to the power 2 because here is 1 multiplied in 2 is 2. Here the second base we have x to the power 1 over 3, okay, so 1 over 3 multiplied in 2. The third base is y to the power 3 over 5, it is multiplied in 2, okay. Let's see the other part. Here we have how many bases? This is the first base, which is 9. This is the second base, x. This is the third base, y. So all to the power half. This means this half will be multiplied in the exponents of each base. Therefore, 9 to the power 1 multiplied in half should be 9 to the power half. X cubed multiplied in half, y to the power 3 over 2 multiplied in half. Now let's continue. So 2 to the power 2 is 4. X to the power 1 over 3 multiplied in 2 should be x to the power 2 over 3. Y to the power 3 over 5 multiplied in 2 should be y to the power 6 over 5. The other part, 9 to the power half, means 9 to the power half equals the square root of 9, which is 3, okay. So this is 3. X to the power 3 multiplied in 1 over 2, so it's x to the power 3 over 2. Y to the power 3 over 2 multiplied in 1 over 2 should be 3 over y to the power 3 over 4. Now let's do combining or multiplying with similar bases. Before that, let's multiply 4 into 3, okay. This is the first thing. The second thing, we will multiply similar bases, x here and x here, and y here into y here. So if you complete, it should be 12x to the power 2 over 3 plus 3 over 2. 2 over 3 plus 3 over 2 multiplied in y to the power 6 over 5 plus 3 over 4. Now if you add the fraction, these fractions together and these fractions together aside, you will find the answer to be 13 over 6 and 39 over 20 respectively. Completing our job here, it should be 12x to the power 13 over 6 multiplied in y to the power 39 over 20, and we are done. Now let's take another example. If we say a to the power 3 over 4 multiplied in b to the power 1 over 2 all to the power over this expression, which is a to the power 2 over 3 multiplied in b to the power 3 over 4 all to the power 3. To answer this is equal to, let's now take this exponent, multiply it into this exponent, and multiply it in this exponent. So this will equal to a to the power 3 over 4 multiplied in 2, b to the power 1 over 2 multiplied in 2, and here a to the power 2 over 3 multiplied in 3, b to the power 3 over 4 multiplied in 3. So this is equal to what? This is equal to a to the power 6 over 4, b to the power 1, a here to the power 6 over 3, b to the power 9 over 4. This can be simplified, by the way. A should be a to the power 3 over 2, b here a should be a to the power 2 multiplied in b to the power 9 over 4. So this is eventually equal to a to the power 3 over 2 minus 2 multiplied in b to the power 1 minus 9 over 4. And if you complete doing the job for the fractions, so completing, this is equal to a to the power minus half multiplied in b to the power minus 5 over 4. This is equal to 1 over a to the power half multiplied in b to the power 5 over 4, and we are done. Let's now take another example. This is an easy example. If you see here minus 5, you can multiply it in minus 4, and these two with similar bases, you combine them together or multiply them together. So minus 5 into minus 4 should be what? Should be 20. And what about x to the power 1 over 3 plus half? This is eventually equal to 20 x 2 plus 3 over 6. So it should be equal to 20 x to the power 5 over 6, and we are done. When we talk about rational exponents, we usually talk about radicals. What are radicals? Radicals are expressed in this notation: the nth root of b. B is called radicand, and n is called the index, where n is always a positive integer. Okay, what is the definition of the nth root of b? The definition of the nth root of b says that the nth root of b is equal to what? It's equal to b to the power 1 over n, provided that n is a positive integer and b is a real number, such that b to the power 1 over n is also a real number. Again, the definition of the nth root of b, the nth root of b is equal to b to the power 1 over n, provided that the first case n is a positive integer, the second case b is a real number, but it should be where b to the power 1 over n is also a real number. For example, if we say now minus 2 is a real number. However, if we say minus 2 to the power half, this is a complex number, not a real number. We won't have a case where minus 2 is a real number, of course, and minus 2 to the power, for example, 1 over 3 is a real number, because this is positive odd, as you remember. However, here positive even, so this is not applicable. Okay, this case here where the b to the power 1 over n is a real number does apply in the radicals. However, this case, which is minus 2 to the power half, doesn't apply in the definition of the nth root of b. Again, the nth root of b is equal to b to the power 1 over n, provided that n is a positive integer and b is a real number, where also b to the power 1 over n is a real number. Please note that if we say the index here is 2 and any number here, this is simplified only for special for 2 without writing it, and writing here is b. This is called the square root of b. Only we use it when the index is 2. Only when the index is 2, we do not write here. Okay, so it is common that it is a square root of b. Now you have to distinguish between minus square root of 25 and square root of 25 and square root of minus 25. Okay, this is equal to minus 5, this is equal to 5, this is equal to nothing. This is not a real number, this is a complex number. Okay, you have to understand that. Here, of course, here the index is 2, and here the index is 2, and here the index is 2, so it is positive even. So if I tell you the fourth root of 25, it is okay, a real number. If I tell you the fourth root of minus the fourth root of 25, it is also a real number. If I tell you the fourth root of minus 25, you know it is not a real number, because we have here positive even integer. In cases we have a positive odd 25, a positive odd here 25, here minus 25, a positive, any positive odd. I just picked 3, okay? And the third root, or what we call it, the cubic root. This is also known, but we have to say it. The third root, or the cubic root of, but we usually say the cubic root. We do not say the third root. So it is here the cubic root. Okay, the cubic root of minus 25. Here the cubic root of 25, the cubic root of minus 25, minus the cubic root of 25, and the cubic root of minus 25. So here it is a real number, here it is a real number, here it is a real number. Since this is a positive odd, if it is a positive odd, you have no problem. However, if it is a positive even, whenever a negative inside the root or the radicand is negative, so it is not a real number, or what you call it, a complex number. So simply the rule, if I say here positive odd, if the index is positive odd, okay, and b here always a real number, no problem with that. And if it is a even positive even, if the index is positive even, and here b should be b here should be greater than or equal to 0, as we talked before in the exponents. It is the same, okay? It is the same but in another form. Let's now take the definition of the nth root of b all to the power m. The definition of the nth root of b all to the power m says that it is equal to the nth root of b to the power m. This is also equal to b to the power m over n, provided that n is a positive integer and m is all integers, so m can take any value. For example, the cubic root of 2 all to the power 2 is equal to what? It's equal to the cubic root 2 to the power 2, which is equal to 2 to the power 2 over 3. Okay. The second example, if we say the fifth root of 3 all to the power 4, this is equal to the fifth root of 3 to the power 4, which is equal to the 3 to the power 4 over 5. Okay. Another example, if I say the sixth root of 7 all to the power 9, this is equal to the sixth root of 7 here to the power 9, which is eventually equal to 7 to the power 9 over 6. To understand this formula more, or this definition more, when the nth root of b is a real number, okay? Remember that b to the power m over n equals to the nth root b here to the power m. What did we do here? What did we do here? We just flipped this over, okay? So m over n here, it came here as n and here m, okay? That's it. You just remember that. So here we have b equals the nth root of b to the power m, okay? That's it. Again, if you going to memorize it, b to the power m over n equals to the, just flip this, here n, here b to the power m, okay? N over m came n and m, okay? This is how you proceed. Or you just can put it like this, b to the power m over n equals to, of course here n, we flipped this first, and here b, without putting m here, we just put it here, okay? We are done. This formula, I think, should stick in your mind. Let's take a few examples. Let's say 5x y all to the power 2 over 3. This can be written as a third root of what is inside, which is 5xy, okay, all squared, okay, all squared. If this question came 5xy all to the power 1 over 3, you know it is the third root of 5xy, okay? If it is come xy to the power half, it is the square root, of course here 2, but we are not going to write it. Okay, so decompose this. Can be said that 5xy to the power 2 over 3 equals, let's say, 5xy the cubic root. Okay, because it is over 3 here. This is it is exactly, let me write it again in more simpler form. So this is equal to 5xy. You can say this is equal to 2 multiplied by 1 over 3, right? And then you multiply, take the exponent of each of one here. So this should be 5xy all to the power over 3, all to the power 2. This is the cubic root of 5xy, and then it should be to the power 2, and this is the final answer. Another example, if I say square root of 2ab all to the power 3, all to the power 3, this is equal to what? This is equal to, you flip here, you know it is 2, so it is equal to what is inside 3 over 2. Okay, so what is inside right now? Inside now we can write 2ab. Okay, this is how you proceed. If I tell you the cubic root of 8 all to the power 4, you know that it should be, this can come inside, as you know before, can be written as 3, 8 to the power 4, then the final answer 8, 4 to the power 4 over 3. Okay, if you decompose this, it should be 8 to the power 1 over 3 all to the power 4. You know this is the cubic root of 8, which is equals to 2, then 2 to the power 4, which is equal to 16. Be careful, you must be careful, okay, when you simplify even roots, when you simplify even roots. For example, the square root of 5 square is equal to square root of 25 is equal to 5. Okay, the square root of minus 5 square is equal to square root of 25 is also equal to 5. So when we say this is x, x can take plus 5 and minus 5. In case of plus 5, the answer is 5, and in case of x was minus 5, our answer was also 5. That is, when x equals 5, the square root of x square equals the square root of 5 square equals the square root of 25 equals 5. And if x equals minus 5, the square root of x square equals the square root of minus 5 square equals the square root of 25 equals also 5. We have the same answer. So this leads us to the definition, or to the knowing what is the square root of x square. What is the square root of x square? If you write x only, you are wrong. However, our answer should be like this: the square root of x square is equal to x when x is positive or equal to 0, and minus x when x is less than 0. That's it. As you know, when x is positive or equal to 0, it is x, the same number, and when x is negative, we don't have x. However, we have the negative of x, which is 5. Okay, again, the square root of x squared is equal to x when x is positive or equal to 0. It is equal to negative x when x is less than 0. I hope this is clear. Now let's take an odd root. If you say x equals 5 and the cubic root of x to the power 3 is equal to the cubic root of 5 to the power 3, 5 to 3 over 3. Okay, so this is equal to 5, which eventually equals x. We didn't do any changes. Okay, when x equals minus 5 and the cubic root of x cubed is equal to the cubic root also to the minus 5 cube. This is equal to minus 5, which is equal to x itself, not minus x like the one we experienced before in even roots. So x here remain the same in both cases. Then we can say in the odd root you don't do any changes. So a general idea or definition of the nth root of b to the power n. Okay, the first case, if n is even natural number, okay, then the nth root of b to the power n equals to the absolute value of b. Okay, if n is odd natural number, the nth root of b to the power n is equal to b. Okay, I hope this is clear and you can understand exactly what do we mean by that. We mean this. Let's say the fourth root of x to the power 4. This is equal to the absolute value of x. If I say the third root of x to the power 3, this is equal to x. Okay, this is equal to x. If I tell you the fourth root of minus 5 to the power 4, if we say the fourth root of minus 5 to the power 4, this is equal to the absolute value of minus 5, which is equal to 5. Okay, if I tell you the fourth root of 5 to the power 4, this is also equal to the absolute value of 5, which is equal to 5. If I tell you the cubic root of 5 cube, this is equal to 5. The cubic root of minus 5 cube, this is equal to minus 5. Okay, in general we use here, it is the same number. If you it is the positive, it comes the positive always. Okay, but if you deal with a variable, do not forget that also. Do not forget that not also, always. Okay, so let's say the 8th root of x to the power 8 is equal to the absolute value of x, not x, the absolute value of x. And if we say the 7th root of x to the power 7, it is equal to x. If we say the 4th root of 16 z to the power 4, this is equal to what? We know the 4th root of 16 is what? 2, right? Okay, you can put 2 outside. multiplied in what? In the absolute value of z. Okay, the fourth root of 16 is 2, multiplied into the absolute value of z. Another example, if we ask you the fifth root of 32 a to the power 5. Okay, here we don't care about writing the absolute value, so the answer would be 32. The fifth root of 32 is what? Is 2, and the fifth root of a to the power 5 is a. Let's now discuss the properties of radicals: the product and the quotient and the index. We start by the product. Okay, if we say the nth root of a multiplied into the nth root of b, what does this equal to? We can find the answer. Let's see how can we find that. The nth root of a multiplied into the nth root of b is equal to what? We know this is equal to a to the power 1 over n. Also this one is equal to b to the power 1 over n. So this whole expression can be written as a multiplied in b all to the power 1 over n, if you remember the properties of exponents. Okay, and this is can be written at the end as the nth root of a b. So our first property here, the nth root of a multiplied into the nth root of b, is the nth root of a b. Okay, now let's take the second property, which is the quotient. Okay, the nth root of a over the nth root of b. This is equal to what? A to the power 1 over n over b to the power 1 over n. This can be written as a over b all to the power 1 over n, which is equal to the nth root of a over b. So our second property, which is the quotient, is equal to the nth root of a divided by the nth root of b is equal to the nth root of a divided by b. Similarly, if we would like to find the index property, let's write here. Okay, the mth root of the nth root of a, this is equal to the mth root of a to the power 1 over n, right? Which is eventually equal to a to the power 1 over n all to the power 1 over m, which is eventually equals to a to the power 1 over n multiplied in m, which is eventually the nm root of a. So when we write the index property, it should be the mth root of the nth root of a is equal to the m multiplied in n here root of a. That's it. Now let's discuss the simplest form of radicals. First, the index should have a power greater than the power of the radicand. For example, if we say the square root of x to the power 5, this is not in the simplest form. Okay, why is that? Because the power of the radicand, which is 5, is greater than the power of the index, which is 2. Okay, the second property or the simplest form of radicals rule is that the index of the radical is as small as possible. For example, if we say the ninth root of x cubed, here the index is not the small as possible, because we can make this as x to the power 3 over 9, which is equal to x to the power 1 over 3. So the simplest form is the cubic root of x. Okay, so here this is not in the simplest form, where the index of the radical is as small as possible. The third rule in the putting the radicals in the simplest form is to rationalize the denominator. Okay, the denominator should be rationalized. For example, a radical written like this, in which it is not rationalized, it is not written in the simplest form. Okay, the fourth rule says no fractions occur under the radical sign. For example, if we say the fourth root of 2 over x cubed, so we have a fraction under the radical sign. This is the radical sign. Okay, we have fraction, so this is not in the simplest form. And that's it. Those are the rules for writing the radicals in simplest form. Now let's take examples to assist our understanding. The first example is to simplify this expression. Okay, what to do to simplify? First thing, you separate those who can be eliminated by the radical and those who cannot be eliminated by the radical. Okay, so ask yourself, what parts here that can be eliminated by the radical, okay, and the parts that cannot be eliminated, okay, that cannot be eliminated. So before that, let's see if we can do something here. Here this 32 can be written as, we know that 32 is equal to 2 to the power 5. However, we are not interested into 5. We can say it is 2 multiplied in 2 to the power 4. Okay, because this will be eliminated by the radical. Okay, so writing this to simplify now, this is equal to 2 multiplied in 2 to the power 4 multiplied in x cubed multiplied in y to the power 4. So again, separate those who can be eliminated by the radical and those who cannot be eliminated by the radical. Here, what are the parts that can be eliminated, that can be eliminated by the fourth root here? The first part is this, 2 to the power 4. The second part is this. And the other parts cannot be eliminated. So, if we eliminate right now, or you can put these two together as, this is equal to the fourth root of 2 to the power 4 multiplied in y to the power 4. Also multiplied in the fourth root of 2 multiplied in x cubed. Okay, so this is eventually equal, this one equal, the fourth root of 2 to the power 4 is 2. We know that. What about the fourth root of y to the power 4? Since this is even, then it is the absolute value of y. Okay, then it is multiplied in what? the fourth root of 2x cube. We can't do nothing. We are here done right now for this question. The other question similar. Pick those that can be eliminated by the radical and those who cannot be eliminated by the radical. So looking at inside the radical, we find that 162, we can do something to it. 162 is equal to 81 multiplied in 2. This is exactly 3 to the power 4 multiplied in what? Into 2. Because 81 is 9 multiplied in 9, which is 3 to the power 2, 3 to the power 2. Then it is 3 to the power 4 multiplied in 2. However, we are interested in the degree of 3. So what can we do here? We can write 3 multiplied in 3 to the power 3 multiplied in 2. Okay, this is how we can utilize 162 inside the radical. So what are we going to do? This is the third root. This is equal to the third root of 162, so it should be 3 multiplied in 3 to the power 3 multiplied in 2, right? What about x4? X to the power 4. X to the power 4 is x to the power cube multiplied in x, because we want to utilize x to the power 3 with the radical of 3. Okay, what about y to the power 6? Y to the power 6, we can do it like this. It is y square all to the power 3, right? Because we want to utilize this 3 along with the third root. So now, as we said before, we will gather those who can be eliminated and those who cannot be eliminated. So those who can be eliminated, let's take the third root of, let's say this is 3 to the power 3, and we have x to the power 3, and we have y square, right? So this is to the power 3, of course. So 3 to the power 3 multiplied in x to the power 3 multiplied in y square all to the power 3. Okay, then it is multiplied in the third root of what is left now, the things that cannot be eliminated, 3 here and 2 here and 1x here. So it should be 3 multiplied in 2, which is 6x. Okay, so all these can be eliminated, so it could be, the final answer should be 3xy square multiplied in the cubic root of 6x, and we are done. If we take another question, in this question we have here the square root. Okay, so we know 18 is equal to 9, so multiplied in 2, right? 9, this is equal to 3 to the power 2 multiplied in 2. Okay, so we are interested in 3 square, right? Going inside the radical, it should be square root of 3 to the power 2 multiplied in 2, right? Also x square here, we will utilize it along with the 3 square, because we have here the number 2, so those will be eliminated, and we have y to the power 5. Y to the power 5 is equal to what? Y to the power 4 multiplied in y, which is equal to y square to the power 2 multiplied in y. So this is equal to, multiplied here we will do multiplied in y square all to the power square multiplied in y, because now we are going to eliminate those underlined. So put them aside. We have 9, okay, multiplied in x square multiplied in y square to the power 2, okay, multiplied also into those who cannot be eliminated, which are the 2 and y, okay, so 2y. Then this is equal to 9. The square root of x squared is the absolute value of x, and the square root of y squared to be squared should be the absolute value of y squared, and we know that the absolute value of y squared always positive, okay, so y is squared, regardless if it is minus y or plus y, it is minus any number or plus any number, it is squared, so should be better not to write the absolute value in here, or you can say the absolute value of any squared number is itself because it is squared. Let's complete our example. 9 multiplied with the absolute value of x multiplied in y squared multiplied the square root of 2y, and we are done. Let me introduce to you like radicals. What are like radicals? Are those radicals that have the same index and same radicand. For example, if we have radicals with the same index and same radicand. For example, square root of xy square, 35 multiplied in square root of xy square, and 9 multiplied in square root of xy square. Those are called like radicals. Why is that? Because we have the same index and the same radicand, okay? However, in cases, if I tell you a multiplied in x squared and I tell you a multiplied in x cubed, those are not like radicals, because like radicals should be the index and the radicands are the same. However, the index here are the same, but the radicand here x squared and here x cubed. Not like the one before. Here we have x y squared, which is the radicand, and the index is 2. Okay, and here the radicand is x y squared and the index is 2. We can combine like radicals using the distributive property. For example, 3 square root of 5 plus 9 square root of 5. This is equal to 3 plus 9 square root of 5, which is equal to 12 square root of 5. Also, if I tell you 4x square root of 3 plus y square root of 3, this is equal to 4x plus y multiplied square root of 3. And that's it. This is how you add like radicals. If there are no like radicals, you cannot add. Okay, only adding when using radicals only used in the case where we have like radicals. Otherwise, you cannot add. Let's take an example to understand how to use like radicals when adding radicals together. 5x multiplied in the cubic root of 16 x to the power 4 minus the cubic root of 128 x to the power 7. What can we do right now? if our question says combine radical expression. We know that 16 equals 2 to the power 4, and we know that 128 is equal to 2 to the power 7. So simplifying this or combining, this will go down 5x multiplied in cubic root of 2 to the power 4 multiplied in x to the power 4 minus the cubic root of 2 to the power 7 multiplied in x to the power 7. We are interested in eliminating those who are in the same degree of as this index, which is 3. So this will go down 5x, and we try to compose what is inside here. So this is 2 to the power 4 is 2 multiplied in 2 to the power 3. Also x to the power 4 is x multiplied in x to the power 3. Okay, minus, we will do the same here. 2 to the power 7 is 2 to the power 3 multiplied in 2 to the power 3 multiplied in 2. Okay, this is 2 to the power 7. Also multiplied in x to the power 3 multiplied in x to the power 3 multiplied in x. Okay, so try to finalize what is inside right now. Okay, this 2 can be eliminated. However, let's just write them down. Here we have 2x, right, multiplied in 2 to the power 3 multiplied in x cubed. Now those who can be eliminated and those who cannot be eliminated. Okay, we are good to go. Okay, of course here the third root, so minus. Now we can do something here. What can we do? Before that, let's take those who cannot be eliminated, which are 2x, okay, together. So let's do something here. 2 to the power in these two things, 2 to the power 3 multiplied in 2 to the power 3. We want something to be at the power of 3 because we have here the third root. So this is 2 square to the power 3. Okay, this 2 to the power 3 multiplied in 2 to the power 3 is 2 to the power 6. So we made it 2 to the power 2 all to the power 3. Similarly, we will do the same in x. So it should be x to the power 2 all to the power 3. Okay, now we can eliminate. This 5x will go down and this will go as 2x outside. We eliminated, multiplied in 2x. Okay, those went here outside of the root or the radical. Okay, minus, we have here these two can be eliminated. 2 square is 4, x square here is x square, multiplied on those who cannot be eliminated, which are 2 and x. Of course here the third root. Okay, so let me write it down better here. Okay, so this is 4x square and multiplied in the third root of 2x. Now here also we have the third root. We have the third root here. We have the third root in here. So now we have what? We have like radicals. As you can see, same index, same radicand. You can combine right now. So if you say that 5x minus 4, not 5x. 5x multiplied in 2x is 10x square minus 4x square. All multiplied in what? Using the distributive property. Of course we use the distributive property, so all multiplied in the third root of 2x. So this is eventually, it will equal to 6x squared multiplied in the third root of 2x, and we are done. Let's take now another example. Minus 3x multiplied in the cubic root of 54 multiplied x squared plus 2 multiplied in the cubic root of 16x to the power 7. To answer this, let's start by decomposing the numbers. We know that 54 is equal to 27 multiplied in 2, which is equal to 3 to the power 3 multiplied in 2. Okay, we know also that 16 is equal to 2 to the power 4. So keep these things in mind. Simplifying this or combining the radical expression, this expression equals to, this will go down, minus 3x multiplied in the cubic root of 54 is 3 to the power 3, okay, multiplied in 2. X to the power 4 can be written as x to the power 3 multiplied in x, plus now 2 multiplied in 16 is 2 to the power 4, so we will write it 2 to the power 3, here is 3 of course, 2 to the power 3 multiplied in 2, okay. And x to the power 7, we can write it as x to the power 6 multiplied in x, as simple as that, okay. So going down, it is minus 3x, so this is equal to 3 to the power 3 multiplied in x cubed multiplied in 2x, okay. We will keep those who can be eliminated and those who cannot be eliminated, okay, plus 2 multiplied in the cubic root of 2 to the power 3, and we can write x to the power 6 as x to the power 2 all to the power 3, okay, multiplied in what? 2 multiplied in x, okay. We have here 2, we have here x, so this will eventually equal to minus 3x multiplied in the cubic root of, or if let's simplify it immediately, so it is equal to minus 3x multiplied in 3x, okay, multiplied in the cubic root of 2x. This 2 multiplied in what? 3 multiplied in 2 multiplied in x squared multiplied in the cubic root of 2x, so this is equal to minus 9x squared multiplied into the cubic root of 2x plus 4x squared multiplied in the cubic root of 2x. So using the distributive property, this is equal to minus 9x squared plus 4x squared multiplied into 2x cubic root, because we have like radicals, okay. So this is equal to minus 5x squared multiplied in the third root of 2x, and we are done. Let's discuss the multiplication of radical expression, the multiplication of radical expression, okay. So how do we perform multiplication? We use the distributive property. For example, if I say the square root of 5 multiplied in the square root of 20 minus 3 multiplied in the square root of 15, this is accomplished using the distributive property. Thus this multiplied in here and this multiplied in here, so it should be equal to square root of 5 multiplied the square root of 20 is the square root of 100 minus 3 multiplied the square root of 5 multiplied the square root of 15 is what? The square root of 75. Okay, so this is eventually equals 10 minus 3. Okay, multiplied in what? This 75, this 75 is equal to 25 multiplied in 3, right? So equal to square root of 25 multiplied the square root of 3. So this is eventually equal 10 minus 3, 3 multiplied in 5, which is the square root of 25 is 5, multiplied in the square root of 3. So it is 10 minus 15 square root of 3. This is how we do multiplication of radical expressions, okay, using the distributive property. If an example comes to you, perform the operation. We have 5 multiplied in the square root of 6 minus 7, all multiplied in 3 multiplied in the square root of 6 plus 2, or between parentheses. So the solution is that this expression is equal to we will take this 5 multiplied the square root of 3, we will multiply it into here first and into here first. Okay, so also we will take this minus 7 and multiply it here and here. So let's see together how is this performed. This would be 5 square root of 6, okay, multiplied in 3 square root of 6, okay, plus 5 square root of 6 multiplied into 2. Okay, now let's go to the other part now. Minus 7 multiplied in 3 square root of 6, and also minus 7 multiplied in 2. So this is equal to, of course, square root of 6 multiplied the square root of 6 means square root of 6 square. Square root of 6 multiplied the square root of 6 equals square root of 6 square. We know this is equal to 6. Okay, 5 multiplied in 3 is 15. So 15 multiplied in 6 here, plus 2 multiplied in 5 should be 10 square root of 6. Okay, then minus 7 multiplied in 3 is minus 21 square root of 6. Minus 7 multiplied in 2 is minus 14. So we have only 2 radicals here. We have 2 radicals and we have 2 constants. Okay, so these two, 15 multiplied in 6 is equal to 90. Okay, what minus 14 together. Okay, so plus 10 multiplied the square root of 6 and minus 21 multiplied the square root of 6. Using the distributive property, 10 minus 21 should be minus 11 square root of 6. We combined like radicals. Okay, using the distributive properties. Okay, then this is equal to what exactly? It is equal to 76 minus 11 multiplied square root of 6, and we are done. If another questions come to you, 3 minus square root of x minus 7 all squared. So how to simplify that, or how to perform this operation? This is exactly equal to 3 minus square root of x minus 7 multiplied in itself. 3 minus square root of x minus 7. Okay, so we will do what? We will multiply first this into here and into here, then we will multiply this into here and into here. So let's do that. 3 multiplied in 3 is 9. 3 multiplied in minus square root of x minus 7 should be minus 3 square root of x minus 7. Okay, then minus square root of x minus 7 multiplied in 3 should be minus 3 square root of x minus 7. Also, minus square root of x minus 7 multiplied in itself, okay, should be negative multiplied in negative, negative multiplied in negative should be positive. So it should be positive square root of x minus 7 all squared. Okay, this is how it goes. So this is 9 minus 3 square root of x minus 7 minus 3 multiplied into square root of x minus 7. This is equal to what? As you remember in the previous questions, square root of 6 multiplied in square root of 6 equals 6, right? Okay, what about this? This is equal to x minus 7 in case where x should be greater than or equal to 7, greater than or equal to 7. However, it is assumed from the question itself, it is assumed that it is greater than or equal to 7. It couldn't be less than 7. If it is less than 7, we will have a complex number. Then we just performed that what we have done is that square root of x minus 7 all to the square is equal to x minus 7. That's here what we have done. So completing our answer and performing the operation, so this is equal to, these are like radicals. Okay, so we will use the distributive property. Also remember that we used the distributive property in the multiplication here. Okay, so the distributive property here, it should be what we have here before. Let's combine now. We have 9 here, and we have here minus 7, and we have x here alone. Okay, so let's say x 9 minus 7 is plus 2. And what about the like radicals? Minus 3 here, minus, and here minus 3, here minus 3, and here minus 3, so it should be minus 6 square root of x minus 7, and we are done. Another question. Now we have 3 multiplying square root of 5y minus 4 all to the power square. How to perform this operation? We will write it as, of course, 3 square root of 5y minus 4 multiplied in itself. Okay, so using the distributive property, so this is first multiplied into here and into here. Okay, so this is equal to 3 3 multiplied in the square root of 5y multiplied with 3 square root of 5y. This is equal to 9 multiplied in 5y. Okay, and also 3 square root of 5y multiplied in minus 4. This is equal to minus 12 square root of 5y. Okay, minus 12 multiplied square root of 5y. Now let's say that minus 4 multiplied in 3 square root of 5 square root of 5y. This is equal to also minus 12 square root of 5y, and minus 4 multiplied in minus 4, this is equal to plus 16. So this is equal to what? 45y minus, now we have like radicals, so we will use the distributive property, so it should be minus 24 square root of 5y plus 16. And we are done. If you remember, when we discussed the putting the radicals in the simplest form, we mentioned that the radical should be rationalized. Okay, that is, the denominator should be rationalized. We don't accept ever a form of like this. This is not a rationalized radical. We need to rationalize this. How do we rationalize such this one or this example? If we say this is it is not in the simplest form, we need to rationalize. Or we have, for example, 5 over the fourth root of x to the power 5. How do we rationalize these things? In order to rationalize these fractions, okay, we must keep in mind the following examples. Okay, let's keep in mind the following example: the square root of 6 multiplied the square root of 6. This is equal to 6. Why is that? Why is that? Because you know this, here 2, right? So this is because this is equal to the square root, we write here 2 for the moment, of 6 square. Okay, this is equal to 6. Similarly, if we write the cubic root of 6 multiplied in cubic root of 6 multiplied in the cubic root of 6, this is equal to the cubic root of 6 cube, right? This is equal to 6. Also, the fourth root of 6 multiplied in the fourth root of 6 multiplied in the fourth root of 6 multiplied in the fourth root of 6, this is equal to the fourth root of 6 to the power 4, which is equal to 6. Keep these examples in your mind when you rationalize fractions that contain radicals. Okay, so how to rationalize a fraction that contains a radical? Well, let's see. If we have 5 over square root of 3, we need to rationalize this expression. We need to rationalize this fraction. Okay, how to rationalize it? Okay, first we will keep the fraction as it is. Okay, now it is 5 over square root of 3. We want to get rid of this square root of 3 not to be in the denominator. Okay, this is how you rationalize. Rationalize means in the denominator there is no radical. So getting rid of what is here, that is no radical in the denominator, we first, okay, write the fraction as it is. We wrote it as it is. So how to get rid of that? We multiply here by square root of 3. We remember that square root of 3 multiplied by square root of 3 is equal to 3. This will help us to get rid of the radical that is here. So if we multiply here by square root of 3, we should multiply here also by square root of 3, because square root of 3 over square root of 3 is 1. So it is like we did nothing that we to this fraction. Okay, like you say 2 multiplied in 1 is 2. You made nothing. Okay, only we need to rationalize the fraction. So when we multiply now, when we multiply, this is equal to what? This is equal to 5 square root of 3 over 3. Now you rationalized. You are done. Let's take another example, more difficult. Not difficult, but you need to understand what you are doing. Okay, over the cubic root of 7. So what to do right now? We need to get rid of this one down here. How to do that? If you remember, that the cubic root of 7 multiplied in cubic root of 7 multiplied in cubic root of 7, okay, this is equal to the cubic root of 7 to the power 3. This is equal to what? 7, okay? This is equal to 7. So, what to do? This is equal 2 over the cubic root of 7. So we need to multiply it into the cubic root of 7 square, okay, or you can write it as the cubic root of 7 multiplied the cubic root of 7, okay. It is the same way, okay. However, we will multiply it by the cubic root of 7 square to make things easier, okay. Multiply the cubic root into of 7 square. So this is equal to what? This is equal to 2 multiplying the cubic root of 49 over what? Over 7. You rationalize. Another question, if it comes to you, it is a very easy, but you need to focus really. 5 over the fourth root of x to the power 5, okay. How to rationalize that? We know that in order to rationalize this, we will write it as it is first. Fourth root of x to the power 5. What to do? So we can do something here. We can do something, if you remember, because this is long, this is very long. If you could decompose what to do, you have fourth root of x to the power 5. Now if you multiply it by fourth root of x to the power 5, multiply the fourth root of 2x to the power 5, you are making things worse. This would be x to the power 10 and x to the power 15 eventually, so you are expanding. However, let's do something which is suiting the situation. If we multiply by the fourth root of x cube, this will be eventually equals to the fourth root of x to the power 8. You can eliminate that. If you remember, the fourth root of x to the power 2 all to the power 4, so this is equal to x squared. So then you rationalize better. So what we will do, we will multiply by the fourth root of x cube, okay, and also multiply here by the fourth root of x cube. So our final answer should be 5 over what? Over x squared, of course, here multiplied by x cube, and we are done. Now let's take an example to assess our understanding. The first fraction to rationalize is 5 over the cubic root of a. This is to be rationalized, okay. We first write it as it is. So how to rationalize? We multiply by the cubic root of a square here and the cubic root here of a square. So this is eventually equal to 5 multiplied the cubic root of a square over what? Over a, and you are done. The second question, the square root of 3 over 32 multiplied in y, provided that y is greater than 0. So this is equal to, we can write it as this, square root of 3 over square root of 32 y, okay. How to rationalize? We multiplied it by square root of 32y, and here square root of 32y. So this is equal to square root of 3 multiplied square root of 32 is eventually equal to here it is equal to square root of 3 multiplied in square root of 16 multiplied into 32 is 16 multiplied into 2 multiplied in y. Okay, and down here we will have 32y. Okay, so completing it should be square root of 3 will be multiplied with the square root of 2 inside, and 16 will go outside. Okay, so 16 will go outside as what? As 4. And square root of 3 multiplied the square root of 2 would be, of course, inside the root would be 6. Y will remain the same over 32. So this is eventually equal to square root of 6y over 8. Now it is in the simplest form. So let's take another example. 2 over the fourth root of 4y. So we will write it as it is first. Fourth root of 4y. Now what to do? So if you rationalize, I would take the fourth root 4y cube. Okay, here also the fourth root 4y cube. So complete your answer. This down here should be 4y, right? And the above 2 multiplied into the fourth root 4 cube y cube. We can do something also here. We can do something. Let's say here 2 multiplied in the fourth root of 2 square to the power 3 multiplied in y cube over 4y. This is equal to 2 multiplied in the fourth root of what? 2 to the power 6. 2 to the power 6. So 2 to the power 6 is equal to 2 to the power 4 multiplied 2 to the power 2. Okay, okay, multiplied in y cube over 4y. This is equal to, of course this will be eliminated and will go outside, should be 4 multiplied in 2 square, here should be 4 y cube over 4. Then these two will be eliminated and the final answer would be equals to square root of 4y cube over y. Here it is y. Okay, and that's it. To rationalize the denominator of a fraction of expression such as 1 over square root of m plus square root of n, use the conjugate of this expression. The conjugate of square root of m plus square root of n is conjugate of this expression is square root of m minus square root of n. Why is that? Because if you multiply square root of m plus square root of n into square root of m minus square root of n, it is equal to m minus n. Always equal m minus n. If you want to see why is that, okay, use the distributive property, multiply this and this, and this and this, okay, also this and this, and this and this, you will eventually get this one. Okay, so for expressions such as this one, you multiply by the conjugate. Here positive sign, here negative sign. This is the conjugate. Okay, if we have square root of m minus square root of n, then multiply into square root of m plus square root of n, and that's it. So how is square root of m plus square root of n multiplied square root of m minus square root of n equals m minus n? How is that? This is the conjugate of this one, and this one is the conjugate of this one. So how did we reach to this conclusion? What we will do, we will first multiply this and this and in this. Okay, let's see how it goes. Square root of m multiplied square root of m, okay, minus square root of m multiplied square root of n. Now we finished the first distributive. Now multiply this into this, multiply this into this, and this into this. So this is equal to plus square root of n multiplying square root of m minus square root of n square root of n. Okay, this is equal square root of m square minus, of course, this 2 will be eliminated. Okay, so this is minus square root of n all square. Eventually it will equal m minus n, and we are done. Okay, if a question comes to you and says rationalize the denominator, okay, we have this example. So what to do now? We will multiply by the conjugate. Okay, so we will first start with the same expression. Okay, 1 minus 4 square root of 5 multiply into the conjugate. So the conjugate is 1 plus 4. This is the conjugate. Also multiply here with the same. So how? So we have down here in the denominator, let's see, this is equal to 1 square minus, okay, what, 4 square root of 5 all square. Okay, as we saw in the example before. What about the above? Here we use the distributive property. We will multiply here first and multiply here first. Okay, and this will be multiply here first and multiply here second. Okay, so 3 multiplied in 1 equals 3. 3 and 3 multiplied in 4 square root of 5 equals 12 square root of 5. 2 square root of 5 multiplied in 1 is equal to 2 square root of 5, and 2 square root of 5 multiplied in 4 square root of 5, then this is equal to 8 square root of 5 square. Okay, so this is, we will combine radical like radicals here, and we will see 3 here plus 12 plus 2 is 14 square root of 5 plus 8 multiplied into 5, okay, over 1 minus, this is equal to 4 square is 16, square root of 5 square is 5. Okay, so our final answer would be equals to this 40 here plus 3 is 43 plus 14 square root of 5 over minus 89. So 89, and here we will put the minus, and we are done. Now let's take another example. 2 plus 4 square root of x over 3 minus 5 multiplied 3 minus 5 multiplied in square root of x, provided that x is greater than 0. So x here and x here cannot be negative. Okay, so how to rationalize? We use the conjugate of this one. Okay, so this expression eventually equals to 2 plus 4 multiplied in square root of x over 3 minus 5 square root of x, multiply here and down and above. Here we multiply by the conjugate, 5 square root of x, here plus, here negative. Okay, if here is positive, you put here negative. Okay, use the conjugate. Okay, 3 plus square root of x. Then we proceed. So this is equal to, let's start with the denominator. So this is equal to 3 square minus 5 square root of x all square. Okay, in the above we will use the distributive. We first multiply 2 and 3 and into 5 square root of x, then we multiply 4 square root of x into 3, and we multiply it into 5 square root of x. So 2 into 3 is 6, and 2 into 5 square root of x is 10 square root of x. What about 4x multiplied in 3 is 12 square root of x, and 4x into 5x equals 20 square root of x square. Okay, now try to simplify as much as you can. Down here we have 9 minus 25 multiplied in square root of x squared. Of course it is eventually x. Okay, now let's go to the numerator. We have 6 plus 10x and 12x is what? Is 22 square root of x. 10 square multiplied in square root of x plus 12 multiplied in square root of x equals 22 multiplied in square root of x plus 20 into x. Okay, so we are done. Now let's take this example. How to rationalize this? So we have here, okay, that we will use the conjugate. So it is minus 7 over 3 multiplied square root of 2 minus 5. Also multiplied it in the conjugate, which is 3 square root of 2 minus plus 5. Now it is plus 5. The same you will do here, plus 5. Okay, so down here we will have in the denominator 3 square root of 2 all square minus 5 all square. So in the above you will multiply here using distributive and here. Okay, so it should be minus 21 square root of 2 minus 35. Okay, so this is equals to minus 21 square root of 2 minus 35 over 9 multiplied in 2 minus 25. So this is equal to minus 21 square root of 2 minus 35 over 18 minus 25 is minus 7. So you can do something here. You can take the negative outside of this, okay, of this in the numerator, so it should be minus 21 plus 35 over, of course, minus 7. And negative and negative will go together, so the answer would be, so here if we take negative and negative should be positive. Negative divided by negative is positive, so the answer, final answer, 21 multiplied square root 2 plus 35 over 7. And if you simplify more, 21 over 7 is 3 multiplied square root of 2. 35 over 7 is 5. And you are done.